Local repository in Maven. Now we are focusing on local repository. The local repository is a directory on the computer where Maven runs. It catches remote downloads and contains temporary built artifacts that you have not yet released. Here you can see the diagram. This is a diagram which shows the defined flow in which Maven to resolve the dependency. Here you can see the step 1 is read. Maven core read project dot here pom.xml. This is related to Maven 1.x, but in the new version from 2.x this will be pom.xml, and then it will build then Maven core will check if artifact is in local repository, and then get artifact from remote repository again, and back again get artifact from remote repository. Then put downloaded artifact in local repository, and thereafter generate files. For example, create jar file here. Here in step 1, Maven core is connected to pom.xml, and Maven core in step 2 Maven core is connected to local repository, and step 3 Maven core is connected to remote repository, and HTTP is passed from during the interactions, and step 4 Maven core is connected to local repository. Here this is JVM1 and this is JVM2 is a web server here. Now we are considering how Maven locates artifact at build time. When building project, Maven implements a simple caching scheme. Artifacts are downloaded from the remote repositories on the internet, and then cached to the local repository. This figure shows an overall overview of procedure that Maven follows when allocating artifact at build time. When building a project, Maven locates required artifact, OSGI, bundles, Kara features, for example, required plugins, and so on, and as follows. The first place that Maven looks for an artifact is the local repository. That's /m2 repository, which is effectively cached where Maven stores the artifact it has already downloaded or found elsewhere. Then 2, an artifact is not available in the local repository. Maven attempt to download this artifact from one of the repository listed in its configuration. These repositories can include both internal and remote repositories. If the artifact is not available from the internal repository, the next repository try a remote repository is accessible through HTTP or HTTPS. For here, when the Maven project is built locally using Maven install command, the project's Maven artifacts are installed into local repository. Here you can see a local repository. Here $ user.home and mem.m2 my repository. Step 1, here the local repository interact with repositories. Here the step 2, file. Here the file colon // here the step 3 http colon // here, and in the step 4 Maven project is connected to a local repository via build, and here you can see in the step 2 and 3 repositories are connected to local repository via Maven and download. Here the Maven project is connected to local repository via build install. Now we are considering how the container locates artifact at runtime. In this is a particular configuration at runtime. With Linux here, the runtime, the process of locating Maven artifact is implemented by Eclipse Ether library, which is bundled in Karaf container, so that it is not necessary for Apache Maven to be installed on the container host. It is possible to customize Karaf containers Maven configuration by editing etc org.ops/pax.url.men.cfg. Now we are considering locating artifacts at runtime. This figure shows the mechanism for handling a Maven URL and resolving Maven artifact at runtime. The step followed to locate required Maven artifacts are the resolution of Maven artifact is triggered when user invokes osgi :install command on the Maven URL, or if a user invokes the features :install command on the feature that references some Maven URLs. To resolve the Maven URL, JVM callbacks on the protocol handler registered against the Maven scheme, which happens to be a pax URL ether component. Step 3, the pax URL ether component reads its configuration from the install dir /etc/org.apache ops4j.pax.url.men.cfg file, and possibly also from a Maven settings.xml file if so configured. Pax URL ether layer passes the requested Maven URL and combines this information with the specified configuration in order to invoke the Eclipse Ether library. When the Ether library is invoked, the first step is to look up any local Maven repositories to try it and find Maven artifact. The following local repositories are configured by default. Step 4. Install directory /system, the JBoss Fuse system directory, which contains all the Maven artifacts that are bundled with JBoss Fuse distribution. the user home m.m2 dot / repository, the user's own local repository, and in the user's home directory, user home. If you like, you can customize list of local repositories to add your own custom Maven repository. If Maven artifact is found locally, skip locally. You can skip straight to step 7 here. In 5, if Maven artifact can't be found in the local repositories, Ether tries to look up specified remote repositories using list of remote repositories spied in the PAX URL Ether configuration. Because the remote repositories are typically located in the internet, accessed through the HTTP protocol, it is necessary to have internet access for this step to succeed. Note, if your local network requires you to use HTTP proxy to access internet, it is possible to configure PAX URL Ether to use HTTP proxy. 6. If the Maven artifact is found in the remote repository, Ether automatically install the artifact into the local, the user's local Maven repository, so that another remote lookup will not be required. 7. Finally, assuming that the Maven artifact has successfully resolved, Karaf install the artifact in Karaf bundle cache. Install introductory /data /cache and load the artifact, usually the OSGI bundle, into the container runtime. At this point, the artifact is effectively installed in the container. Here you can see the Karaf console here. This is specific configuration in basically Red Hat. I'm showing this to show how the container locates artifacts at runtime with Maven. Here the Karaf console is here, the step 1 here. Here the OSGI install Maven, and step 2 here Maven etc. And Karaf console is connected to PAX URL Ether, and step 3 the PAX URL Ether is it interacts with etc ops4j.pax.url.maven.config here. You can see local repository equals and default repositories and repositories settings, etc. And this CFG interacts with title.m2 settings.xml Maven settings file. For the Eclipse Ether stateless, it interacts with system directory, custom repository, and Maven local Maven repository. Here the system directory is here karaf.home / system. Here custom directory path to custom repository here, and local Maven repository here user home, and then m.m2 / here repository. Step 5 here the Eclipse Ether stateless is connected to HTTP proxy remote Maven repositories here. Step 6 here the is connected to Maven local Maven repository, and step 7 the install the Karaf bundle cache is connected to Karaf bundle cache via install. Here you can see how Maven dependencies work. The image here show how Maven dependencies workflow during entire build process. Each step represented by arrow moved the dependency from one point to next. The step is run by the phase execution. Maven dependency management come from the pom.xml file inside project's root folder. Dependencies list is written in the pom.xml. Here you can see with regarding dependencies, here the other repositories are connected to local repository via compile paste, and here the Maven center repository is connected to local repository via compile paste, and here the /.m2 the local repository, and local repository is connected to projects folder target /target projects folder via package face, and project folder is connected to local repository via install paste. As an example, we can consider Maven install. In the paste install the package into the local repository for use as a dependency in other projects locally. Here you can see local repository. This value is the path of this build system's local repository. The default value is $user.home then .m2 then repository. This element is especially useful for a main build server, allowing all logged in users to build from a common local repository. This is in settings.xml file. So in interactive mode, true if Maven should attempt to interact with user for input, false if not, default to true. Offline, if this build system should operate offline mode, default to false. This element is useful for build servers which cannot connect to a remote repository, either because of network setup or security reasons. As an example 3, we can consider this one, include custom library into Maven local repository. Here download the captcha extract, download the captcha, extract it, and copy the captcha dash $version jar to somewhere else, for example C drive, and run this command. Then captcha, the captcha jar is installed, copied into your local into our Maven local repository. Now we are considering interface local repository in package org.apache.maven.api. The local repository is used to cache artifact downloaded from the remote repository and hold artifacts that have been built locally. Now we are considering base version artifact property in Maven local repositories. As noted in the layout page in the documentation, locally built and installed implies the local repository artifact use base version while calculating layout. Hence, in this case, both base version and version of them will both contain same value. One editing with snapshot contains constant string, no transformation is applied to the file name. Snapshot pulled from remote and cached in local repository have the timestamped version property instead. Hence, they will have the full blown timestamp version applied to the name. Now we are considering settings. In settings, the root here the root element local repository, the root element of user. In the settings, the root the element local repository, the local repository in settings, the root element of the user configuration files. The default value is the this one user home /.m2 /repository. The type is string. With regarding API, we can consider method at not null public settings.builder local repository string local repository in class settings.builder in package org.apache.maven.api.settings. Here we can consider some CLI, Maven CLI options reference. Here the option dash LLR or dash legacy dash local dash repository. This is unsupported and use of this option will make Maven invocation fail. And here we are considering plugin, considering supported by Maven project in available plugin. Is that plugin install the build artifact into the local repository. This is type build, and source repository is git/github. With regarding API, we can consider the field public static final lifecycle phase install in enum lifecycle phase in package .api.plugin.annotations. Now we are considering how do I create jar and installed it in my local repository. Making a jar file is straightforward enough, and that can be accomplished by executing the following command here. You can now take look in the base directory /target directory, and you will see the generated jar file. Now you will want to install the artifact you have generated the jar file in your local repository. user.home/m.m2/repository is the default location. And do so, execute following command here. Upon executing this command, you will see the following output. Note that the Surefire plugin, which executes the test, contained in files with a particular naming convention. By default, the test include **test.java and **test.java and **test case.java, and the default excludes **abstract test.java and **abstract case.java. You have walked through the process for setting up, building and testing packaging and installing a typical Maven project. This is likely vast majority of what projects will be doing with the Maven, and if you notice, everything you have been able to do up to this point has been driven by the 18-line file, namely the project model of POM. If you look at the typical and build file that provide the same functionality that we have achieved thus far, you will notice it is already twice the size of the POM, and we're just getting started. There is far more functionality available to you from Maven without requiring any additions to our POM as it currently stands. To get any more functionality out of this example and build file, you must keep making error-prone additions. So what else you can get for free? There are a great number of Maven plugins that work out the box with even a simple POM like we have. Using this example, we will without any work on your part, this POM has enough information to generate a website for your project. We are not showing the POM here. It's a simple POM, and you will most likely want to customize your Maven site, but if you are pressed for time, you will need to provide basic information about your project is execute the following command. There are plenty of other standalone goals that can be executed as well. For example, here, this will remove the target directory with all built data before starting so that it is fresh. So scanning project here. Nothing to compile, all classes are up to date here. Here the tests running com.mycampaign.app test here. Here the results. with the building jar, and here build success. Here we are considering guide to installing third-party jars. To install a jar in the local repository, use following command. Occasionally you will have third-party jars that you need to put in your local repository for use in your build, since they don't exist in any public repository like Maven Central. Jars must be placed in the local repository in the correct place in order to be correctly picked up by Maven, Apache Maven. To make this easier or less error prone, we have provided an install file goal in the Maven install plugin, which should make this relatively painless. To install a jar in the local repository, use the following command. If there is a POM file as well, you can install it with the following command. With version 2.5 of Maven install plugin, it can get even simpler. If a jar was built by Apache Maven, it will contain a pom.xml in subdirectory of meta-inf/directory, which will be read by default. In this case, all you need to do is this. Here the path to file, and here the group ID and artifact ID here, the version and packaging here. Here the path to file, and here the path to POM file. Here the path to file. Here we are considering configuring your local repository in configuring Maven. The default value is $user.home user.home/.m2/repository. Note the local repository must be an absolute path. With regarding API, we can consider the method at not null public settings.builder local repository string local repository in class settings.builder in package apache.maven.api.settings. Now we are considering I have a jar that I want to put into my local repository. How can I copy it in? With regard to sequencer's technical question. If you are not confident about the layout of the Maven repository, then you can adapt the following command to load in your jar file in all on one line. If you understand the layout of the Maven repository, you can copy the jar directly into where it is meant to go. Maven will find this file next time it is run. If you are not confident about the layout of the Maven repository, then you can adapt this command, following command, to load in your jar files all in one line. Path to file, group ID, artifact ID, version, packaging, and here the packaging. Example we can example we can consider this one. Here the local class local repository not accessible exception signals a failure to store files within a local repository, and this is in package org.apache.maven.repository. And here you can see could not create local repository at /test artifacts from /m2 repository. And as an error example, we can consider this failure to execute goal on project X, could not resolve dependencies for project X, failure to find Y in archive repository was cached in the local repository, Resolution will not be reattempted until the update interval of internal has elapsed or update are forced